Good afternoon. Thank you for joining us today. Welcome to Respirable Crystalline Silica, Strategies for Compliance and Effective Exposure Control Plans, presented by the Ferry Group at Nolfisk. My name is Maxine Chang, Senior Marketing Specialist at Nolfisk, and I will be your moderator today. This presentation will be about 45 to 50 minutes of content with the remaining time for Q&A. During the webinar, if you have any questions for our speakers, please submit them via the questions pane. We will also follow up with all registrants with a copy of the recorded webinar and presentation slides. Now I would like to introduce you to our presenters. Abby Ferry is the president of the Ferry Group, LLC. Abby holds a master's degree in environmental science and safety, is an OSHA outreach trainer for construction, and a certified safety professional. She is responsible for risk control, program development, training, and regulatory compliance for construction, manufacturing, energy, beverage, hospitality, and retail clients throughout the US and Canada. Mark Cunningham is a business development manager for building construction at Nolfisk. Mark has more than 30 years of experience in various facets of the building and construction industry. With Nolfisk, he is responsible for market strategy and product development specific to solving silica dust challenges. Finally, Steve Mitchell, who will be joining us during the Q&A portion. Steve is a sales training manager at Nolfisk and is responsible for training internal and external Nolfisk associates on applications, regulations, and products related to industrial cleaning and dust mitigation through the Americas. Just a quick disclaimer, Nolfisk Inc., the Ferry Group, and the presenters here are not authorized to approve equipment for your facility or job site. The opinions discussed in this webinar are our opinions only. Finally, you should consult with your employer or designated competent person before determining the safest approved solution for your facility. I will now turn the presentation over to Abby, and she will review the learning objectives.
Hi, thank you. So the learning objectives for the webinar, a little bit ambitious, but we'll get to it. I want to make sure that you're able to describe the elements that you need for an exposure control plan per the OSHA standard, that you're able to understand Table 1 and understand your requirements for exposure assessment at your sites, also to understand the requirements for tools and dust mitigation, housekeeping at your sites, and finally to identify resources for further study on this topic. Next slide. All right, so just in case you haven't refreshed yourself or that you have not found information on the standard, I'll go through just a quick background on it. Next. The effective dates have already passed, especially the top two here. June 23rd, 2016 is when the standard for construction became effective. In September, just last month, all obligations of the standard except for the analysis of the samples, which is going to be effective next June 23rd. So as of September 23rd of this year, all parts of the standard except for the sample analysis are now effective and enforceable by OSHA. Next. If you still want to read some more about the rule, you could read the entire rule and its preamble, which actually includes a lot of really good information, especially in the preamble. So I do encourage that if you are the competent person or qualified person at your company to work on this written exposure control plan, is to read that preamble. Maybe not the full 600+ pages, but you can find it at the link, and the presentation will be available to you for download after the session. So I encourage you to navigate to these links. Also, the regulatory text is about 26 pages, and that is on OSHA's website. Next. Exposure levels that are new with the new standard, they are expressed as an 8-hour time-weighted average. So the new permissible exposure level for respirable crystalline silica is 50 micrograms per cubic meter, and the action level is 25 micrograms per cubic meter. So if you you were to read OSHA's preamble, they go into discussion about how even at these exposure levels, that exposure is still significant, but they felt that it is the lowest level feasible with the different types of controls that we have available to us in industry. Next. Some exclusions for the standard is that if your exposure as you measure it stays below 25 micrograms per cubic meter as an 8-hour time-weighted average under any foreseeable conditions, then you can be excluded from the standard. And of course, the any foreseeable conditions is highlighted because that is something that you would have to prove. If you are analyzing your sampling and finding that you think you can be excluded, make sure that you can define those working conditions. Next. Objective data is another part of the standard where OSHA has some of their own objective data, and also there's some data that's out there in industry. So from OSHA, if you're under 25 micrograms per cubic meter as an exception, then you don't need objective data to support this. OSHA found in their inspections and evaluations and analysis of sampling that they've done for silica in the past is that mixing mortar, pouring concrete footers and foundations, and removal of concrete formwork, when they're done in isolation, that they're not generating a significant exposure. So no exposures over 25 micrograms per cubic meter were found when OSHA went through their sample analysis for those 3 different tasks. Next. Some more objective data from OSHA. They found under the action level, which is at 25 micrograms per cubic meter, when drilling holes in concrete or masonry or other tasks involving silica exposure that are done by kind of non-concrete related trades like carpenters, plumbers, and electricians. And this is when there was occasional brief exposures to respirable crystalline silica, that these particular workers doing these tasks were found to be under the action level. Next. There was a situation described in the preamble about dry drilling on a wall on the lower level of a concrete parking garage with poor air circulation, kind of to describe a worst case scenario. And in a 15-minute exposure, the person was exposed to 300 micrograms per cubic meter and averaged out for an 8-hour time-weighted average. Their exposure was actually under the action level and found that to be at 19 micrograms per cubic meter. So it depends on the amount of time that a worker could potentially be exposed to the silica containing dust. And that's why a theme throughout this webinar is going to be to make sure that you're sampling the work that your workers are doing, to make sure you can understand the exposure that they may have depending on the tasks that they do. Next. Drywall finishing is not included in Table 1 of the final standard because OSHA pulled a bunch of drywall compounds from retail stores that were labeled silica-free or reduced silica or other type of wording and tested those NIOSH tested those and found that there was less than 0.5% of silica found in these compounds. So the general objective data and guidance suggestion from OSHA is for drywall finishing companies to use silica-free materials and or engineering controls to minimize workers' exposure to respirable crystalline silica. Next. All right, so Table 1 next. When you look at Table 1, make sure that you read it properly, that OSHA intends that you are in compliance as long as you have fully and properly implemented the controls that are described in Table 1. And the OSHA, the standard as it's currently on OSHA's website, it's kind of difficult to download just Table 1. So I've got my website link there where you can download just an easy Word file of Table 1, and you can use that for your resources at your company in your written program. That's at theferrygroup.co/resources. Next. So Table 1 describes 18 different scenarios of different equipment or task activities, and they have described engineering and work practice controls as well as respiratory protection with specific assigned protection factors, APFs. So that's what Table 1 is, if you have not already taken a look at that. So Table 1 includes things like describing engineering controls like water delivery systems, dust collection, and HEPA filtered vacuums. And also they specify 99% or greater efficiency or filter cleaning mechanisms, which is what Mark will talk about later on when we discuss products for dust control. Next. So my suggested approach with Table 1 is that you should identify all the tasks that you have at your company that could expose workers to respirable crystalline silica. Just don't even look at Table 1 yet. Just identify the different tasks that your workers do that involve concrete or potential exposure to silica dust. Then take that list of what your workers actually do and compare it to the list that OSHA has developed for Table 1. So you might find that most of your tasks are somehow listed on Table 1, and some will be left out. So that's okay. That's pretty normal for companies, construction companies doing routine construction work, that not everything's going to be covered on Table 1. So for the tasks that are on Table 1, look at what those controls are and make sure that you are able to implement those controls. Now, if you can't fully and properly implement the controls on Table 1, we're going to have to talk about alternative exposure control methods. So just save that for later. I suggest using contract language if you are a general contractor, construction manager, or other kind of host employer, to take a look at your contract language to make sure that subcontractors and service providers and vendors that you use that may create their own exposure for respirable crystalline silica, that you include in their contract that they're responsible for following the controls in Table 1. Next. So in general, for Table 1 controls, that if the task is being done indoors or in an enclosed area, that there needs to be some kind of exhaust ventilation to make sure that you're not accumulating visible airborne dust. And I've talked to a lot of OSHA consultation personnel, and kind of the main theme has been no dust. So no dust clouds, trying to minimize these visible dust clouds as much as possible at your work sites. So then we have work practice controls to limit entry into those areas. So if there's workers who are not required for that specific task, just minimize their access to the areas where there's potential respirable crystalline silica exposure. And then in the construction environment, when we have multiple trades that may be exposed to or creating silica-containing dust, there's an issue of area ventilation and who's responsible for that. So that's another one of those suggestions that I have about looking at contract language. And I don't know if this has happened yet, but maybe general contractors or construction managers providing general area ventilation. That's a business decision. So that would be up to the individual contractors. Next. So OSHA's main emphasis with Table 1 is on engineering controls. And as safety professionals, we know that this is where we should be starting with controls when we identify a hazard in the first place. So I don't think most of us that are safety professionals on this call that we really need to be reminded that engineering controls are more reliable and predictable and consistent because there's less potential for human error. It's something that we can monitor, and it also lowers exposure in the general area for other workers. So engineering controls are going to be the best thing for silica exposures on the work site. Next. OSHA also gets into wet methods and HEPA filter methods within Table 1. And in construction, we know that these may not be safe or effective in all situations. So Table 1 may tell you specific guidelines on how to control the silica dust, but if it's something that's not feasible in your workplace, then we have to look at the alternative exposure control methods. The standard does say that OSHA prohibits dry sweeping, dry brushing, or compressed air for cleaning. So that language means that we shouldn't be doing these activities and creating silica-containing dust. And in the preamble, OSHA mentioned that they expect this type of activity to be extremely limited anyway. So if you are using compressed air for cleaning, you've got to use ventilation to get rid of those visible dust clouds. And whenever possible, not doing dry sweeping, dry brushing, or using that compressed air for cleaning, to follow Table 1 whenever possible. Next. So alternative exposure controls, I've alluded to that a little bit. So this is a section of the standard that we're supposed to look to when the tasks that our workers do are not listed on Table 1, or if you've looked at Table 1, your tasks are on there, but you're not able to fully and properly implement the controls that Table 1 describes. So there's an entire section of the standard for alternative exposure controls, and it can get to be a little complex, so we'll get into that here. Next. So alternative exposure controls are really reliant on air sampling, finding out exactly what the exposure is to your workers on the site. So the first option is what's called the performance option. And again, it's very specific, and this is to assess the 8-hour time-weighted average for each employee. And when the standard says each employee, they really mean each employee. And as I've talked to some consultation personnel with OSHA, they have, I don't want to say relaxed, that's the wrong word, but realizing that to be practical, it may be necessary to sample a representative group of workers. And so if you are choosing that route, make sure that you're choosing kind of that worst case scenario. And so you're using air monitoring and or objective data that relates to those specific tasks and employees. Next. Then we have the scheduled monitoring option. So there's multiple parts to this, and I really should make a flow chart based on this because it does get kind of complex, because each next round of testing is based on the previous. So you would conduct an initial 8-hour time-weighted average sample for each worker using one or more breathing zone samples on each shift, each job, or each work area. So here again is where you would need to identify representative sampling candidates based on worst case scenarios. So if it's some kind of grinding operation, making sure that you're finding the worst case scenario, that it's indoors, little ventilation for the most amount of time that a worker could potentially do this task. So representative samples to me means go for worst case scenario in each type of task, shift, or site that may differ. So as far as construction is concerned, this is not to say that you need to do air monitoring and sampling at each new job site. That's not the intent of this. You may have the same types of operations that occur at many different job sites and different jobs in the future. It's not necessary to sample at each one, but as long as you're finding representative sampling for each type of task that's done on job sites currently and that could be done in the future, that's going to satisfy the scheduled monitoring option. Next. So part 2 depends on what you find in the initial monitoring. So if the initial samples are coming back under the action level, then you don't have to do monitoring anymore, so you can stop right there. If the initial testing samples come back at or above that action level of 25 micrograms per cubic meter, but at or below the PEL, then you have to repeat sampling within 6 months. Now, if that initial sample is above the PEL, then you've got to repeat monitoring within 3 months, so a little bit quicker. And also take into consideration in the standard, you've got to notify workers when you're conducting sampling and what the outcome of every sampling project ends up being. So it needs to be some kind of posting where you let the workers know what the PEL and the AL are compared to the actual samples that were taken in their work area. Next. So you're continuing on your scheduled monitoring, whether it's within 3 months or 6 months, and then with your next sample, whatever the most recent, not the initial sample, if it's below the action level, then you've got to repeat the sampling within 6 months until you get 2 back-to-back measurements that are 7 or more days apart under the action level. So then you can stop monitoring unless you otherwise have to do it based on new tools, equipment, processes, or other signs of a new exposure. Next. And then, of course, when there's changes in production, other work practice types of changes, or maybe you take on some more concrete and silica exposure type of work, or there's a new product that you're using in your process, then conduct some more monitoring so that you can make sure that the workers are not overexposed. And so any labs that you're using for sample analysis must follow Appendix A of the new standard. And that's the last remaining part of the standard that is not effective yet. So that's going to be effective next June, June 23rd of 2018 is when the entire standard will then be enforceable. Next. So employee notification of the sampling and the outcomes, this is something that has to be done within 5 working days of receiving the information from the lab. And it has to be in writing, and you should post it, and also include in that posting corrective actions when the sampling is over the PEL. And I've had clients that have had the samples that are above the AL, but under the PEL, and still including information about corrective actions. And another thing that people are finding as they do silica, respirable crystalline silica sampling, is that when they're doing also sampling for total respirable dust, that they may be under the action level or PEL for silica, but they're over the action level or PEL for total respirable dust. So be mindful of that, especially if you're sampling for multiple things in the dust, that information needs to be included in the notification to the workers. And also, as with any notification or training for your workers, make sure it's understood, that it's clear, that some of these things, there's lots of big words, or they may not understand the sampling methodology. So make sure that you're communicating this information in plain language so the workers can understand. Next. All right, so choosing the right tools for dust control, I think this is when I hand it over to Mark.
Yes, thank you, Abby. Local exhaust ventilation systems, or LEV, is referred to in the standard in multiple places, including Table 1. And what they're recommended for construction applications when you're using concrete grinders, cutoff saws, tuck pointing, things like that. What it really means is it's collecting the dust at the source of the dust generation. So at the drill, let's say, or at the grinding wheel, or at the cutoff wheel. And the LEV system would consist of a shroud that's going to enclose most of the cutting wheel. Would include a hose, a flexible hose, and an industrial vacuum. These LEV systems can help reduce respirable crystalline silica dust exposure by 5 to 20 times. Housekeeping procedures. Now, housekeeping isn't mentioned specifically in Table 1, but it is mentioned in the standard. It's called out specifically and was stated earlier. Prohibits the use of compressed air, dry brushing, and dry sweeping for cleaning surfaces and clothing, and unless recommended methods are not feasible. So what it does do is it promotes the use of wet cleaning methods and/or HEPA filtered vacuuming for all housekeeping involving silica dust collection. Vacuum filtration requirements. These are called out specifically in Table 1 and other parts of the standard. And for cleanup or housekeeping, high efficiency particulate air filters, or HEPA filters. According to OSHA's definition, a HEPA filter is 99.97% efficient in removing particles of 0.3 microns in diameter. True HEPA filters are individually tested and certified by a third party. In contrast, some HEPA filter manufacturers will batch test HEPA filters. So you may get one tested out of a batch of several hundred. Be sure to ask for certification for individually tested HEPA filters. Dust collectors, they're filters with a capture efficiency of about 99% or greater for respirable particulate. Example filter efficiency range will be from 99% at 0.5 microns down to 99.97% at 0.3 microns. Okay, the importance of filtration. A multi-stage filtration or graduated filtration is what most industrial type vacuum systems would be using. And in the picture on the upper right, you can see a cutaway of an industrial vacuum. First part of filtration would be the cyclonic action, where larger particles are directed to the collection container. Next part would be the main filter or the workhorse of the filtration system. Most of the fine particulate is captured in the main filter. What you're looking for is a large surface area of your filter, or a low air to cloth ratio. The cyclonic separator is going to prevent larger particles from perforating that main filter. And then last in the filtration defense line would be the HEPA filter. So most of the particles have been filtered already through the cyclonic filtration and the main filter. The HEPA filter is going to be filtering those very small particles and down to 0.3 microns, 99.97% effective. The standard also addresses filter cleaning. So the bottom left-hand corner of the picture or the slide, you'll see a pull clean method where you're actually causing the airflow to reverse, and it forces the dust on the main filter off the sides of the filter. So that's cleaning it by doing this pull clean. The slide in the middle, or the picture in the middle, is showing you manual filter cleaning. We actually shake the filter after periods of time. And then the picture on the right is just showing you the different types of gauges that could be used. Pressure gauge that will show you when the filter needs to be cleaned as the pressure builds up. Okay, there are some specific vacuum cleaner, industrial vacuum cleaner requirements for grinder, concrete grinding applications, where it will specify the airflow requirements of the vacuum based on the diameter of the grinding wheel. So it's 25 CFM, cubic feet per minute, per inch diameter of grinding blade. So for example, if you're grinding with a 5-inch diameter grinding wheel, you'd need to have a vacuum that has at least 125 CFM airflow. We'll also tell you that that vacuum needs to be equipped with a cyclonic pre-separator, like we talked about in the last slide, to collect the large pieces of debris before it reaches the main filter. And then a filter cleaning mechanism, like the pull clean system, or even an automatic cleaning system like the InfiniClean method. Other vacuum requirements calls out for central vacuum systems that are allowed, but the discharge of respirable crystalline silica must be outside of the work area. Also, the hoses connecting to the tool should be intact without any kinks or bends, because that could lower the airflow through the vacuum and wouldn't be able to suck the amount of dust that was intended to be moved. So we'll get into that as well. Some features you should look for in industrial strength vacuums. First, rugged, durable. They're going to be used on construction sites, so you need to have a machine that's going to be able to stand up to the impacts and the wear and tear that would be expected on a construction site. So corrosion-resistant materials, impact-resistant plastics, perhaps even some steel-type vacuum systems. different collection options, whether you have collecting directly into a container, or if you've got a bag first that it's going into. Wet-dry models, can the vacuum collect wet and dry, or is it wet or dry only? Those are the types of things you should be asking yourself. And ergonomic design, so it should be easily moved, should be portable, shouldn't be tipping over easily, so you're looking for something that is portable and easy to move around. Auto tool outlet, that's a feature that you should be looking for if you're using the tool with a grinder or a drill, perhaps a cutting tool. This feature will allow the vacuum to start when the tool starts, and it will also allow the vacuum to run for about 30 seconds after the tool stops. So it's collecting all of the dust, not only at the beginning, but also the dust that would be generated and in the hose during the cutting. Low decibel level, this goes without saying, you want to have a vacuum that's quiet, so you're not having the worker or workers around them using air protection. So a quiet, low decibel level vacuum is desirable. And then even having a pressure gauge that can tell you that the filter is operating the way it's supposed to be. And then when it gets into a red zone, let's say, that the filter needs to be cleaned. Lastly, there are different options available for collecting. The picture on the right side there shows what's called a continuous bag or a longo pack. And that bag allows you to collect the silica dust without the worker ever having to touch it or to breathe in any flume of dust when it's time to remove the bag. Some recommended work practices when using the vacuum systems. First, keep the exhaust entry point flat against the surface, so where you're collecting the dust, having it as close to the surface and flat is the most desirable. Shaking the hose periodically to make sure that any settled or accumulated dust at a bend would be collected by the vacuum, so it's not building up there. Working against the rotation of a cutting blade or a grinding system, the tool should be flat in position so that the local exhaust ventilation system will work properly. Changing the vacuum cleaner bags before they become full or before you would have a tear, let's say, so it should be checked periodically, and you want to make sure that you're not overfilling it or preventing the CFM from reaching its maximum. Having the vacuum cleaner below the work level to keep dust from falling back into the hose is a good idea, especially for any applications that might be done on a scaffold. You want to have that vacuum below the source of cutting or source of grinding. And let's just say, even when all of these dust collection methods have been done, respirators may still be necessary, and that'll be called out in Table 1. Abby, I believe we're back to you now with the written exposure plan.
Yes, back to me. You can go to the next slide. All right, so the different parts and pieces of the written exposure control plan are spelled out specifically in the OSHA standards. So the first thing, and which I mentioned earlier in the webinar, is to identify your tasks that include respirable crystalline silica exposure. So if you don't know what those tasks are, you could use things like whatever your company's current scope of work is, tasks that you've done in the past or that the workers are doing now, and also job hazard analysis or job safety analysis, activity hazard analysis, other types of work task forms that you've used in the past could be good sources of information for you to identify tasks that include potential for exposure to silica. Next. Then probably the largest part of everyone's written program is going to be the description of controls. So for many of your tasks, you may just be referring to Table 1 or copy pasting parts of Table 1 into your program, and that's fine. And then for tasks that are not on Table 1, you've got to spell out what controls you're going to be using and identifying those situations where the engineering controls may not be feasible and that you're going to be using work practice and PPE controls. So then this is going to flow into your exposure monitoring program as well. I put the ASTM logo on this page because there is a ASTM standard, and I don't remember the name off the top of my head or the number of the standard, but I've got it later on in the presentation. So there is an ASTM standard out there that spells out a lot of really good respirable crystalline silica controls that are already established and have been tested, and that could be used in construction for tasks that are not covered on Table 1. Next. So engineering and work practice controls, you should use them unless they're absolutely not feasible. And again, if you're finding that engineering and work practice controls on Table 1 or alternative controls are not feasible, make sure that you have some solid reasoning to back that up. If the controls that you're using do not reduce the worker exposure to at or below the PEL, then you've got to use respiratory protection. Next. So respiratory protection, I put that in parentheses because it's not specifically called out in the Silica standard, but most of us, if we already had some respiratory exposures for the workers, we have a respiratory protection program in place. So as part of your development and implementation of this respirable crystalline silica plan, make sure that you revisit your respiratory protection program as well. And so you can use 1910.134 as your guide. And whenever Table 1 requires the use of a respirator, you've got to comply with OSHA's existing respiratory protection program. So respiratory protection should be worn when the Table 1 controls are not fully and properly implemented. So if you're not able to completely follow what Table 1 says, respiratory protection is most likely going to be involved in the task. Also, if there's a break-in time or a certain amount of time where workers need to take to actually install or put into place the engineering and work practice controls, and they may potentially have a higher exposure to respirable crystalline silica, then respiratory protection would need to be worn at that time. And of course, whenever the PEL is exceeded, workers would need to have respiratory protection on. Next slide. So the employer would be in compliance when respiratory protection is worn as prescribed in Table 1 and also following the procedures that are in the established Respiratory Protection Standard 1910.134. So the Silica standard brings together not only respiratory protection, but also hazard communication. So yes, there's this new Silica standard, but it also brings in some updating that you may have to do on your respiratory protection and hazard communication, which I'll get into in a minute. Next. Housekeeping, and Mark talked a little bit about housekeeping. So again, OSHA is talking about instances that compressed air, dry sweeping, or dry brushing would be used. And in those cases, OSHA wants to or is telling you that those types of controls are prohibited. So some clients that I have here locally have been using a sweeping compound. So there is there's many sweeping compounds out there that you could be using as part of your dry sweeping. So I guess it wouldn't really be considered dry sweeping at that point if you're using a sweeping compound. But again, OSHA prohibits the use of any dry applications of housekeeping. Next. Procedures to restrict access to the work areas where there is a potential for respirable crystalline silica are another important piece of the new standard, especially on construction sites where we've got multi-employer work sites where there's many different crews that are working next to each other, right before each other, right after each other, with those potentials for being exposed to respirable crystalline silica, even if your crew didn't create the hazard. So multi-employer work sites, that involves the way that we look at a hazard. So we think about who created that hazard, who can correct it, who's controlling the site, and now I'm blanking on the fourth multi-employer designation, I'll think of it. So OSHA does expect employers or the competent persons of the different employers to work with the general contractor to try to keep down the respirable crystalline silica exposure to all workers that are on the site. So if your crew is the one that's creating the hazard, then you've got to make sure that you're able to control the hazard of the respirable crystalline silica down to an acceptable level. And if you can't, so that would be if your workers are wearing respiratory protection, then you would have to put in other controls to make sure that other workers cannot come into that work area, because it's presumed that they wouldn't be protected and that you would be exposing them to high levels of respirable crystalline silica. So you've got to limit their access to your work area. And as I've talked to OSHA consultation personnel, their suggestion, and also the suggestion in the OSHA standard and preamble, is to use work scheduling to avoid exposure. And so looking at production meetings and even sequencing of the schedule of a construction project to make sure that a crew that's creating a dust hazard isn't creating that hazard for others that may not be on their crew. Next. So I guess to wrap up that, that restricting access using things like signs or just plain old communication at coordination meetings to make sure that other crews who aren't involved in the silica operation or where there's respirable crystalline silica exposure, that those personnel are kept out of that immediate work area. So now, and well, even before the standard was fully effective, general contractors were asking their subs and business partners for their written exposure control plan. So your plan, as you write it related to the OSHA standard, it's got to be available to workers, just like any other written safety program, that workers should be able to take that plan, be able to look at it, can make copies. Union representatives, OSHA, other authorities should be able to see that program. And of course, like with any other safety program, that you're reviewing it as operations change, and at least once per year, taking a look at your written program to make sure it still meets your needs. Next. Competent person is, or a competent person is required for respirable crystalline silica exposure on a site. So it's important that you designate a competent person who understands your written exposure control plan, no matter the size of the employer. So this is something that came up, I think mostly when the National Association of Home Builders was having some questions about the proposed silica standard a couple years ago. And that problem was that there's many small companies that have respirable crystalline silica exposure, and so they have a small crew that may be on different job sites. So that just means that more people would have to be trained to that competent person level to make sure that the people, no matter the size of the crew or the company, that they're able to represent their employer at a particular job site if there are issues that come up related to respirable crystalline silica exposure, that competent person is able to speak to what the plan says and table 1 and how the controls are going to be implemented. Next. And real quick too, there's a, I think it was the CIH, there's an industrial hygiene, AIHA published a competent person white paper on just what it should mean to be designated a competent person for this respirable crystalline silica standard. And it's very in-depth. It's a really good piece of information, and it's something that might open a lot of eyes as far as who you're designating as a competent person for this topic at your work sites. So that's from the AIHA. And I don't have that link in this presentation, but I could find it for when Milfis does a follow-up with you all that have attended this webinar. All right, so in summary, next slide. Here's your checklist if you have not done these things yet already. So your exposure control program, the first step is to make sure that you identify all the tasks that your workers do that have a potential for respirable crystalline silica exposure. Then the next step is to compare those tasks to OSHA's Table 1 list, and also to update your respiratory protection program if needed based on what Table 1 is telling you should be the controls, and also to make sure that you're investing in efficient and compliant tools. So I realize it's a big investment for some companies to have the right HEPA filtration vacuums or the proper wet attachments, hose attachments that would go to specific tools. But it's going to save you time and money in the long run as far as compliance to this standard, and especially for worker health and well-being. The next checklist there is to implement alternative exposure controls if you have tasks that are not covered on Table 1, or if you cannot fully and properly implement the controls described on Table 1. Next step is to conduct training, and this is a big one. There's a large part of the OSHA standard that talks about the specific training that workers should have related to respirable, crystalline, silica. So it talks about things like smoking cessation training, which means telling your workers that they should consider quitting smoking if they have silica exposure at the job site. And that's spelled out in OSHA's preamble. So that's a pretty interesting part of the preamble where it talks about smoking, cigarettes, and exposure to respirable, crystalline, silica having a synergistic effect with each other. Conducting training also if your competent people that you'd like to designate are not up to that competent person level. So supervisors, equipment managers, those that are putting the attachments on the tools or maintaining the HEPA vacuums, there's an element of training that has to go along with all of this to make sure that the engineering controls are maintained and also used on the job site properly. And then the last step, as with any safety program, is to evaluate the progress and adjust as needed. So depending on the controls that you've chosen, there may be an adjustment period to make sure people are using them properly, or you may find that a wet method that you're using is not good enough for what you need on the job, so you may be using a different engineering control. So whatever that means at your workplace, just make sure that there's a method for you to be able to check and make sure that these Table 1 controls or alternative exposure controls are working out and what to do if they don't. Next. Here's a resource, that ASTM E2625 from 2009. It's the standard practice for controlling occupational exposure to respirable, crystalline, silica for construction and demolition activities. And I want to say it's $25. I'm not sure. It might be more than that, but ASTM ANSI standards are available for purchase and download straight from astm.org from that link right there. Also, silica is not a new topic to OSHA. They've been focusing on it for a long time. The Special Emphasis Program began in 1996. So that's where you might recognize that graphic from. And so the Silica landing page or eTools landing page is there at the link on the page. So that's where you'll find any publication or resource that OSHA has done in the past 20 plus years related to silica. So lots of good information there. Some of it's been there for a while. Some of it's a little bit newer. Next. Also, CPWR, the Center to Protect Workers' Rights, they developed a tool called the Create a Plan, which is at the link there. It has some limitations because it basically fills in information based on questions and your answers, and then generates a PDF document. So we know with the PDF, it's kind of hard to edit those. So it's a good plan builder. It's a good place to start if you don't have anything yet. The Silica landing page for OSHA, osha.gov/silica, another good source of information, as well as NIOSH at cdc.gov/NIOSH. They have their silica topic indexes right there, and there's a lot of good information there. Also, NILFISC has silica information as well right on their site. Next. All right, so I think I did okay on time. Well, I think I'm going to open this back up to the moderator at this point for questions.
Yep, thank you so much, Abby, and thank you, Mark, as well. Remember, if you have any questions for our speakers, please submit them via the questions pane. We do have a couple questions, so we'll just kick off the Q&A session now. Steve, maybe you can answer this first question for us. Can HEPA filters collect wet material?
Yeah, Maxine, yes. We have quite a broad offering at NOFISC of HEPA vacuums, HEPA filter vacuums that can collect wet material. As a matter of fact, a lot of the vacuums, you don't even have to change the filter out to collect between wet and dry or wet or dry pickup. However, you really should check with the vacuum manufacturer. Some of the manufacturers require you to add a pre-filter or even actually change out certain filters for wet pickup and versus dry pickup.
Thank you, Steve. The next question is about vacuums as well. Do you have to use the vacuum with a bag?
Some vacuums do work best with a bag, but they're not required to have a bag. And really, the reason why you have a bag in a vacuum is to assist you really in collecting your material and disposing of the material. And what that does, it helps you minimize the pluming of dust and exposure to your workers. And just makes it much easier to empty the collection container. And really, when you use a bag, you can cinch the bag up either with a wire tie or tie a knot in it, or even use some duct tape on it.
Thank you, Steve. Abby, maybe you can take this one for us. What will OSHA inspectors be looking for?
I tried to ask some of my clients and other business colleagues if they've had any OSHA inspections related to silica yet, and nobody's talking yet. So I don't have specific information from out in the field, but just my general take on what the most, kind of contentious parts of the standard. I think a big thing is going to be evaluating worker training. And so that would be twofold, making sure that there is a competent person on the site that's designated to handle respirable crystalline silica, the topic and the program and worker training. And what OSHA inspectors do more now, from what I hear, is that they interview the workers directly. So I think OSHA is going to look for demonstrated knowledge on the part of the competent person, that they're actually able to answer specific questions about the standard and the employer's program. And so that would trickle down to the workers conducting the tasks too. So if you're on a job site where you're doing work that you're creating a dust cloud, or doing work where you're disturbing a concrete surface, be ready for questions from a compliance officer. And that could be even down to the worker doing the task, where they could be asked about training that they've had. When was their last HAZCOM training? When was their training on silica, and what do they know about it? Do the workers know about silicosis and that there's 3 different kinds? And do they understand the synergistic impact of smoking with silica exposure? Things like that, I think, are what the OSHA compliance officers will be looking for, because the standard really does lean heavy on worker involvement, worker training, and understanding why they're using what they're using as far as the engineering and work practice controls. Then I think the other part that will be interesting to see how it plays out is the multi-employer work site issue. So understanding or making sure that they can demonstrate that other people, other crews aren't allowed in respirable crystalline silica potential exposure areas, and how that's actually being done. Is it that they're talking about it in coordination meetings? Is there postings or other type of work practice controls? I think those are going to be the biggest things.
Thank you, Abby, for your thoughts on that. This one is for Mark or Steve. How do I properly dispose silica dust once it's collected?
Okay, so the actual disposal of the material is going to be up to the company or organization that's collecting it. And the recommendation would be to check with any regulations that might apply to your specific job site, or perhaps even the contract construction documents may address disposal of the material. Keep in mind that silica dust is considered a carcinogen, so all applicable local and state, even federal laws will dictate what happens and they vary from state to state, sometimes from municipality to municipality. The last thing is if the material is going to be collected in a bag. I mentioned the continuous bag or longo packs that are available on some vacuum systems. You're tying that in a knot at both ends. So sealing it would be advisable. If it's not a continuous bag, then a wire tie or duct tape, or just simply tying it in a knot will reduce any future exposure or potential for tearing.
Okay, thank you, Mark. Another one for the NOFIS team. Do you have a list of power tools that can be used with your vacuums, and do you offer adapters?
We have adapters that will fit a variety of shrouds that would be used on grinding tools, cutting tools, and some drilling materials as well. So we don't have specific shrouds for specific tools, but we have adapters for the hose to fit over, which would then fit into a variety of different types of shrouds.
Thank you, Mark. Abby, this is a good question. Has OSHA given any clarification on what would constitute a good faith effort to meeting the new standard?
I wish I could answer that. So the good faith effort, that refers to a letter or a memo, that OSHA published. I think it was on September 23rd when so September 23rd was the delayed date of enforcement of everything in the Silica standard except for the lab sampling and analysis stuff in Appendix A. So on September 23rd, OSHA basically published this memo and said that we're going to give you 30 days, another 30 days of, I forget the exact term they use, but it's almost like a graduated in type of enforcement. So in this first 30 days, which we've got about 6 days left of this time period, that OSHA was going to evaluate job sites and look at good faith efforts, that employers would not receive a citation as long as there were good faith efforts being employed. And then there were no examples of what that would be. So I could only guess and say that if you had a written exposure control plan that was started or was actually in place, or if you had training conducted or had training scheduled and coming up, if you had equipment on site like HEPA filter vacuums or wet attachments for the tools, or you had them on order, that those could possibly be considered good faith efforts. But without specific instruction from OSHA on what those actually were, I can only speculate on what the good faith efforts would be. And I hadn't thought about it, but I guess we're less than a week away from when that time period expires anyway. So potentially there could be another memo on October 23rd that could say something else about enforcement. So I think I'm sure a lot of colleagues in the construction industry may be waiting for that October 23rd as the real effective date of the standard, and maybe awaiting some communication from OSHA.
Thank you, Abby. And maybe you can help out with this one. And this will actually be the last question for this webinar. And that is, how would you measure cubic feet of airspace if working outdoors?
You guys want to take that on the product side? I'm not sure how to answer it.
I'm not positive on how that would be measured either, because, they direct for central vac systems to have the exhaust outside of the building. I think, from a practical standpoint, if you can see dust being generated, there's a dust cloud. That dust cloud should be addressed through some type of dust containment system.
I'd agree on that. And I think also with Table 1 spelling out those engineering controls, that they're mainly talking about indoor applications or enclosed applications where you could calculate the CFM or how many cubic feet you've got in the area. So I guess I'd have to go with that. I'm not exactly sure how to answer it any further.
Okay. Well, we are going to follow up with all the attendees. So if we did not answer your question, we will get an answer out to you. Thank you again, Abby, Mark, and Steve for presenting today. We will also follow up with a recording of the webinar and presentation slides so you can pass along to your colleagues. For more information about the Ferry Group and services, please visit www.ferrygroup.co. To learn more about NOFIS vacuum products, please visit www.nofisindustrialvacuums.com. You can also reach out to us via the following social media channels listed on the slide. Thank you again for joining us today.